Hello, welcome to Ecofunomics. This is lecture 5 of data analytics using Excel. So in the last class, we completed central tendency, and today we are going to look into dispersions and relations. Okay, so beginning with my introduction, I am Shreya Roy, and I am the founder and owner of Ecofunomics LLP. And the book which I am using for the course is Excel 101, and it is written by me and my colleague Jyoti Agarwal about Ecofunomics LLP. It is an international education research data analytics company currently serving knowledge across 156 countries as of August 2024. And we are registered under the Ministry of Corporate Affairs, Ministry of Education, Ministry of Commerce and Industry, MSME, all under Government of India. To know more about the data analytics course, please write to us, DM us, or comment down below, and you will also find our contact details over here. Website, email ID, and contact number. This is also our WhatsApp number. Now, let's begin with our course for the day. Today, we are looking into additional formulae for statistics. We are going to cover variance, standard deviation, covariance, correlation. If you want to get your hands on this book, please again write to us. You will have plenty lot of exercises and practice questions and all the formulae in this book. Let's begin with variance. So variance is basically a statistical measure which measures the spread of numbers in a data set from the mean. So basically, if you have a mean and how spread the data is, the degree of dispersion of the remaining observations from the mean is what variance calculates. If I can show you a so basically, let's say this is my mean or the normal data. So how scattered my data is in terms of degree is what variance calculates. This is the formula, basic formula for variance. Now, variance can be calculated using two methods. One is the sample method, one is the population method, two of which we will be using in our Excel study in a while. Now, moving to standard deviation. So standard deviation is again, which measures the same thing as Excel does, but measures how spread the deviation is. So variance is basically measuring the degree of dispersion, and standard deviation measures the scatteredness of the deviation. Okay, so if the data is small standard deviated, that means that the data are more concentrated near its mean value, and if it has a large standard deviation, also known as SD, if it has a large standard deviation, basically it means that the data points are scattered and hugely distant from the mean value. Okay, so variance is represented in sigma square or S square, whereas standard deviation is represented as the square root of variance, which means either a sigma or an S. Repeating, variance is represented symbolically using a sigma square or S square. Standard deviation is square root of variance, and hence it is represented as sigma or S. If I can show you a PPT. Okay. It is represented with X and its formula is square root of variance. We will first understand variance and standard deviation and then move into covariance and correlation. So, is equal to var dot P stands for population. Select the entire data, close the bracket, enter. Is equal to var, I am repeating, is equal to var dot P. Select your data, close bracket, enter. Okay, now let us also understand the difference between population and sample. So population basically means, let us assume, let us understand using what the term actually means. So India has a huge population, right? So population, when we say population, population to the layman people in layman language basically means the citizens of a country, right? So entire thing is known as population. Very good. Now, when I say sample, what I mean, out of the population, if I pick up few people, okay, it can be randomly, it can be planned. For example, if I say out of India, if I pick up a few states, let's say the people of West Bengal, people of Kerala, people of Maharashtra. So those then becomes my sample, okay? So similarly, again, if you are studying West Bengal as a whole, then the West Bengal in total becomes your population. And from there, if you pick a few people, let's say from the districts of Malda, from the districts of 24 Paragon, then that becomes your sample. Okay, so it is always in relative terms. The whole thing is known as a population. And from that, if you pick up something, that becomes your sample. So smaller the sample size, greater the chances of error, larger the sample size, lower the chances of error and biasness in your data. Sample size tending towards infinity or towards population, error tends towards 0. I hope I was able to explain myself. Now, let's understand what happens if I want to calculate the variance sample is equal to var dot S, which stands for sample. Let's take 1/4, close bracket, enter. Okay, so here we see in the first half of the quarter, we have received a lower variance value, whereas for the entire year, we have received a higher variance value. So we can say in the first quarter, the data was closer to the mean, but when we took the entire annual data, the data is farther away from the mean. Okay, now let's take a look at month and rainfall is equal to var population, select the entire data set, close bracket, enter, is equal to var dot sample. Let's take for half yearly data, close bracket, enter. Okay, so we see in this one, when we take the first half of the annual data, the variance is higher, somewhat higher than the annual data variance. Okay, moving to standard deviation, which basically calculates how far away scattered your data is from mean, is equal to STDEV dot P, open bracket, standard deviation dot population, select the entire data range, close bracket, enter, is equal to, obviously the variance value is going to be higher than the standard deviation value because standard deviation is the square root of variance. Okay, is equal to ST dev.s or standard deviation dot sample, selecting 6 months, close bracket, enter. Okay. So when we take half year, we see it is more dispersed, and when we take the annual data, it is relatively near to the mean. Repeating the same for my second data set, which is equal to ST dev.p, select the entire data set, close bracket, enter, is equal to ST dev.s, select 6 months, close bracket, enter, and now we see that, okay, so we have the similar results. 6 months is more further dispersed, whereas annually it is relatively closer in comparison to 6 months. If you have any doubts and if you want me to clear them, please get in touch. Do not hesitate. Write to me. I will reply to your comments, reply to your doubts, definitely. Now, let's understand. Okay, so what is the difference between standard deviation and variance? So standard deviation is the spread of a group of numbers from the mean. Okay, so mean is there, and how spread or scattered your other observations are from your mean. On the other hand, variance is, it measures the average degree to which each point differs from the mean. Average degree. For example, I'm saying that this is my mean and these are the points scattered. So on an average, how distant is these points from the mean? Standard deviation measures the scatteredness. Variance measures the average degree, okay, of scatteredness. Covariance. Let's understand covariance. So covariance in mathematics and statistics is a measure of relationship between two random variables. It can be positively covariated or positive covariance or negative covariance or no covariance at all. Okay. We have to understand that covariance okay. So basically, covariance will only tell you the relationship between two random variables. Let's say there is one variable x and let's say there is another variable y. Okay, so the relationship between these two variables x and y is what covariance tells us. Now, what is the task of correlation? Correlation tells us the magnitude of this relationship. Okay, so covariance will tell you it is either positively related or negatively related or not related. Correlation will tell you the magnitude, how strong is the positive relation, how weak is the positive relation, how strong is the negative relation, how weak is the negative relation. Okay, so are we clear? Covariance tells us the relation, correlation tells us the magnitude or strength of the relation. Okay, let's look into some examples. For covariance is equal to covariance sample. Here, please understand, I have so many of my students making this error. It is not select one cell and select the other cell. If you do this, it is an error. Okay, this makes no sense, because if you pull this down, okay, over here, have a look. What does this sense make? This makes no sense. Okay, this is gibberish. So when you're doing covariance or correlation, please know you have to select the entire variable 1, comma, entire variable 2. Here my variables are profit and expense, okay? And close bracket and enter. And these are gibberish. This makes no sense. Okay? I am repeating. Is equal to covariance population. Select the entire variable 1, comma, select the entire variable 2, close bracket, enter. Okay? Now let's take a look at covariance sample. Covariance dot sample, covariance dot s, select 6 months, comma, select the variable 2 6 months, close bracket, enter. Okay, are we clear? Let's do one more exercise. Is equal to covariance population, select the entire data, close bracket, select the second data, close bracket, and enter. Is equal to covariance sample, select 6 months, close bracket, comma, select the second 6 months, and then close bracket and enter. Okay, so a lot of time what happens while I'm teaching, I might be saying something mistakenly wrong. Please follow what I'm doing on the screen, because I might sometimes be focused so much on what I'm doing, so I might utter wrong words. For example, I have been saying close bracket when I was actually pressing comma. Okay, so please be careful with what I'm saying and what I am doing. Please follow the screen and do not, you might overlook to what I am saying. Okay. Okay. Now let's take a look and understand. Okay. So the covariance over here is positive and the covariance over here is negative. Okay. Understood? Now, when we have a positive covariance, we say that X and Y are positively related, meaning as X increases, Y will also increase. Okay. However, when we have a negative value, we say as X increases, Y decreases. I am repeating. If the covariance is positive, we say as X increases, Y also increases. If covariance is negative, we say X increases, Y decreases. There's an opposite relationship, okay? Or X decreases, Y increases. There's an opposite relationship. But when there is a positive value, it is in the same direction, okay? One increases, other one also decreases. One decreases, other one also decreases. Please understand, and if you have any doubt, get in touch. So covariance tells us the relationship, whether it is positively related or negatively related. Now let's look into correlation. Okay, is equal to CORREL, open bracket, select the entire data range for the first variable, comma, select the entire data range for the second variable, close bracket, enter. Okay, so now again pay attention, because correlation basically has it can range from -1 to +1, okay, with 0 in the middle. So -1 to -0.5, it is strongly negatively correlated. Okay, -1 to -0.5, strongly negatively related. Okay, -0.5 to 0, almost 0, but not entirely 0. Okay, -0.5 to almost 0, weakly negatively related. Okay, if it is 0, no relation. Okay, 0, almost 0 to positive 0.5, weakly positively related. Almost 0 to positive 0.5, weakly positively related. Positive 0.5 to 1, positive 1, strongly positively related. I am repeating. Please pay attention. -1 to -0.5, strongly negatively related. -0.5 to almost 0, weakly negatively related. 0, no relation. Almost 0 to positive 0.5, weakly positively related. Positive 0.5 to positive 1, strongly positively related. I hope you understood. Okay. Now, here we have 0.24, which is weakly positively related. Okay. Now, let's take a look over this one. Okay, let's even do this one. Is equal to CORREL. Select the first data range, select the second data range, close bracket, and enter. Again, 0 point. So sales and expense has very weak positive relation or correlation. Is equal to CORREL. Select the first data range, comma, select the second data range, close bracket, enter. Here we get 0.8335, which is 0.834, which is strongly positively related, which means as sales increases, profits also increase. Okay, so I am repeating again, covariance will tell you the positive or the negative relationship. If the two variables are positively related, which means as one increases, other one also increases. As one decreases, the other one also decreases. If they are negatively related, one increases, other one decreases. One decreases, other one increases. Okay. And for covariance, it tells you the magnitude. Weakly, no, strongly negatively related, weakly negatively related, no relation, weakly positively related, strongly positively related. That's about it for this class. I hope you learned something new. If not, you brushed your old memories, and these all formulae, these all topics are extremely crucial for data analytics point of view. So if you have any doubt, get in touch. If you want to purchase the book, get in touch. If you want to know about the course, get in touch. If you liked the video, like and subscribe. And see you in the next week. Probably next week, next class, whenever it is possible for me. Until next time, bye.